only the processor it's working on will acknowledge that. Like if you disable interrupts on one processor, all the other processors don't care. Like they haven't had their interrupts disabled, they're still busy doing their thing. The TSL lock locks the memory bus entirely, so none of the processors can use it while the one that locked it is busy in there.
Okay, very good. And group 4?
Okay, so you said earlier that mutex gets implemented to the monitor. Is that what you guys said earlier?
Yeah, so when you use the monitor class in a specific language, basically what it's doing is it's just coding the mutex locks for you. Okay. So you just have to specify that like this chunk of code is inside of this monitor. So it'll like write the locks for you.
Okay, so this is my question now. So why not use Semaphore? Is it just because it's less efficient? Is that why? What was that? Why not use the Semaphore?
Semaphore.
Oh, Semaphore?
Oh, Semaphore, sorry.
Well, no, it does. So semaphores are more, they're more complicated for, like you can use them in the producer-consumer problem, but in like, you know, production level resource usage patterns, like with huge programs, it's gonna be more complicated than just on and off. So what the monitor does for you is I think it does use them, but it just kind of sets them all for you. So you don't have to worry about the order of unlocking and locking.
You can use any of those structures to solve the problem that they had. A mutex, a semaphore, or what did you guys use for your program?
Mutex.
A mutex. Yeah, so you can use any of those really to solve that particular problem. Okay, and the next group, group 5.
The barriers, is that like a software system, or could that be like a hardware thing within the processor?
It's like a software system. It's basically a primitive, like a code or something that the processors have to execute before they can go into the next step.
Okay, and group 6.
In message passaging or message passing, what were the two system calls?
Send and receive. Like send sends the message to a destination, and then receive receives it from a source.
Okay, good question. And group 7.
Earlier you suggested that taxing the kernel can prove inefficient, like mutexes, or if you can elaborate just a little bit more on that.
So, with an operating system with a whole bunch of processes going on, if you have multiple mutexes tapped into the kernel, it'll eventually consume quite some memory. So, if you have a few texts where it doesn't actually do that, it'll be less harsh on the kernel. So,
Okay, and group 8.
I have a question. So that video, like, what were you trying to define the goals? Because it looked like you were just running that video. So what was like the main topic, like idea that you were supposed to get out of it?
I think basically it's just showing why you would need different threads running at the same time. So like one guy's cooking and one guy's chopping the vegetables. And that's pretty much it. Just kind of like situations where you need it.
Yeah, they didn't show the whole video course. We need you, the videos that you choose should be like 2 to 3 minutes max, because we don't have time for more than that. That's why we had to stop that video, but they were trying to show like each one of these guys being a separate thread, so that's good. And the last question, group 9. Sorry, go ahead.
So I think you already touched on this kind of a little bit, but if mutexes are more efficient than semaphores, why would you use semaphore then?
semaphores are more flexible compared to mutexes. Mutexes simply locks and unlocks, as for semaphores can be used for other things such as synchronization and ordering processes. It's just simply more flexible. Mutexes will be used in a simpler system that doesn't require a lot of complexity, and it requires a lot less space, it's more efficient and faster.
help with scheduling. Like if you have multiple processes that depend on each other, you can get them to run in that order because one will block for the next, Whereas with utexes, it's just it either can go or it can't. So you have to have some other code to get that correct order. So you can just do it all with the semaphore.
Yeah.
You have that instance where you have a hierarchy.
Very good. Did we have group 9 ask a question? Or?
That was us.
Okay. Now, could you please write your number